Hello and welcome to the Market Herald Studios. I'm Talia Seaton. Today I'm welcoming back Iggy Tan, Managing Director from Altec Chemicals, to the studios. Iggy, thanks so much for joining me.
Nice to see you again, Talia.
Iggy, talk us through what is this game-changing breakthrough that you've announced to the market?
Well, as you know, we've been working on this project for 12 months now, and I'm happy to say we have finally cracked the silicon code, and we have successfully produced lithium-ion batteries that are 30% higher energy density, which is really game-changing for the lithium battery industry. So very excited, breakthrough technology. Imagine lithium-ion batteries at 30% higher energy.
So Iggy, I understand there is barriers for the use of silicon in batteries. What are these barriers?
I guess if you follow Tesla, they are probably setting the vision for lithium-ion batteries, and they want to get their cost of production below $100 per kilowatt hour. And Elon Musk has publicly stated that silicon is a promising anode material that has to be in their batteries. Now, silicon is 10 times the energy capacity compared to graphite. So from a layman's point of view, just imagine there are 10 times more sites that the lithium can stay on. But the problem is, today silicon is not used in commercial batteries because of essentially two problems. The first problem is that the silicon particle expands 300% in volume and fractures. And the second problem, it absorbs 50% of the lithium on its first charge, and this is called the first cycle loss. So if you can imagine 50% of your lithium is absorbed and becomes inactive, that is a major problem for the battery. So unless you resolve these two problems, you'll never get silicon in your lithium-ion batteries. And we've managed to crack this silicon code.
So tell us, how did Altec break the silicon code?
Using our alumina technology. Essentially, we coat the silicon particles with 2 nanometers of alumina coating, and that prevents or reduces the fracture and also reduces the first cycle loss. And we have now a battery that operates at 30% higher energy. So if you want to talk about technical terms, a lithium-ion battery anode operates around 330 milliamps per hour per gram. Our batteries are operating at 430 milliamps per hour per gram. So you can see a 30% energy increase. And this is significant for the lithium battery market and the potential electric vehicle market.
Okay, so what are the next steps then for Altec Chemicals?
Well, the research has been headed up by our chief scientist, Dr. Jinwan Lui, and all our testing is done in-house in our laboratories. We not only coat the silicon particle or the graphite particle, we take it into batteries and we do the performance tests of these batteries, and so we can see the long-term performance and the energy density of these batteries. So the next phase will be to go beyond the 30%. But today, with a 30% increase, it is a game-changing breakthrough for the industry. Not many people have been able to crack the silicon code and to get silicon operating in a battery like we have.
Well, thank you so much for your time today, and we'll enjoy watching the journey for Altec Chemicals.
Thank you for having me.